So my parcel arrived today. What do we get? Right, okay. Ah yes, this is what I ordered. It's Halloween. It's spooky time. So I picked up a little circuit board. It looks like this. I think that's pretty cute. So what else do we have in here? We got 4 nuggets. We'll talk about those later. And we got nuggets on sticks. Let's have a closer look. So here we have all the components that are in the bag. We have this bag full of LEDs and resistors. I've seen these before, but I've never used one, so I'm curious as to what they are. Also, somewhere in here, there it is, there is a strange yellow orangey thing. That should be fun. We have this little circuit board itself, which is very cute. All these little connecting bits here, these are called traces, and they're just what provides power to other components and allows for data transfer if you wanted. So that's how all the power will be transferred through that. We have a 90-degree header for the Raspberry Pi, so that will just sit on top of the Pi like that. And then when it's all put together, that will go in there, and that will sit on the Pi like that. Now you're probably thinking, hang on a minute, if that uses all the pins, how are you going to do the wiring to control the lighting? Well, for this particular project, we don't need to, because of these little nuggets. Where are the nuggets? These are nuggets, those are nugget adapters. These are IC chips, and I've not used these before, so it's interesting to see how it'll work out for me. Essentially, they're little chips that have pre-programmed bits of code on them. And according to the instruction on this thing, I should be able to just plug it all in, and it will work. So we'll see how that goes. And these don't directly go into the circuit boards. They have these little sockets that they sit in. They stack on top of each other like that. It's probably the wrong way around. Oh, it's the right way around. That will do nicely. So yeah, that's something else. So we have those 2 nuggets and the nugget adapters. This is just the bag that the Pumpkin circuit board came in, and if you follow this link, you will get through to an instructional, tutorial that will show you how to do it. So over here we have my terribly slow Android tablet, and this is what I bought. Now you can see there are the options of a pre-soldered kit for £10. That's what it will look like at the end. Or a soldering kit for £9. And that's the one I bought, because I've not yet shown any soldering on this channel. In fact, I haven't done any myself. So that's what it is. If you want to buy one, it's on thepihot.com for £9. Postage is about £3. And somewhere down here, hopefully we have the link to the instructional thing. If not, I'll just type it in myself. And here we go, the soldering guide for this project. So there's the plain circuit board as we have in the box, list of all the components, and it says what we need to do, which is pretty handy. So we're going to be starting with the back side of this, except that's not what's showing on here, that's showing the front side. Oh, I'm being an idiot. That's why. So, let's have a go at this first step. First thing it says is to start by adding the 8.2k ohm resistor to designator R1. 8.2k has a stroke pattern of grey, red, red. Now resistors, you can see they have little stripes on them. Now that is grey, red, red. So that's the one we want. That one has brown, so it's not that one. This one has no red and purple, so it's not that one. And don't run away, I need you. And this one is something else. Now it's very important you get these the right way round, because if you do this incorrectly, you may well make your thing go boom. So this goes into R1. R1. Now these types of resistors don't have a polarity, so they can go in either way. I should really get my soldering iron heated, shouldn't I? So here's an angle you haven't seen before. What I've done is I've put a microfiber cloth down to protect my table, and I've put the circuit board on a pink sponge to protect the cloth while it protects the table. It makes sense, whatever. So first things first, my soldering iron has been plugged in for a few minutes. It is now hot. I have a wet sponge on hand, ready for dousing. If dousing be needed, it certainly will be needed. Need a pair of choppy boys to do some chopping. First thing you need to do when you turn your soldering iron on for the day is you need to solder the tip. Now, unfortunately, I can't get this in frame, but basically what that means is you just put a little bit of solder on the tip of the soldering iron, let it melt all over it, and that just sort of primes it ready for use. And then, you hear that? That's my hot soldering iron on the sponge. So that is ready to go. So the way this works, from all the tutorials I've watched, you don't actually heat the wires. What you do is you touch the tip of the soldering iron to the metal pad, the little metal ring there. For a few seconds, you let it heat up, you pull the soldering iron away, and you go in there with the solder, and the residual heat that's left over will do the melting. So, this is scary. Let's give it a go. That didn't work. Well, it's melted, but it's not in the hole. Let me reposition myself to give myself some more room to work. Let's try that again, shall we? So I have the solder to hand somewhere. Here I have it. I'm going to heat the pad with the tip of the soldering iron, and I'm going to go in, and it's going to do... Oh my god, I done it. Lani, I did it.
Nice, well done.
Hey. Right, so there's the first one. Heat the pad with the tip and gently push the solder into there, and that looks good. Wow, that's impressive. Right, so now I'm going to dunk my soldering iron on my sponge. This isn't actually an official case for a soldering iron sponge. It's a bit of biscuit packaging that I cut to shape and then stuck a normal sink sponge in there. So that goes there. Now, let's pop the soldering iron back in its stand, which is very important that you do, or you could just drop it like I've done. Let me get back to you in a second. Crisis averted. Now that the solder's in place, I can take it off the sponge. Now I can see there's a little bit of burn on the circuit board, on the pin. The two rods are in place, and what I'm going to do is I'm going to take my wire cutters and I'm just going to clip those off. Now those are off. I just have about 1 billion more components to go. So let's get started on the second one, shall we? The next resistor we need is a 10k ohm resistor, which is black, brown and orange. Or maybe it's whatever that order is. Where is the camera? There you are. So we're going to do the same thing that we did last time. Put these away in the bin. Now this time the resistor is going into the R2 socket that is right next to the first one we did. Very satisfying click into place. I'm going to stay zoomed out for now because that was an absolute nightmare first time round. Soldering iron at the ready. Solder at the ready. Here we go. Well, this isn't going very well, is it? I'm clearly doing something wrong here because I can feel the heat travelling up this length of solder, but it's not melting on the pad. So, what am I doing wrong? Maybe that end is simply too manky and needs chopping off. So I'm going to give that a trim. And I'm going to give this a second go. Now, I want to make very obvious here that solder, used solder, like that little bit I just cut off, cannot go in the normal bin. At least this solder can't because it is lead based, and lead, as most people know, is poisonous. So you need to keep your solder trimmings separate from everything else, all the other bits of rubbish that you're creating when doing this, and need to dispose of them separately. So I think I've realised what I'm doing wrong. It's the angle. I just need to approach it from a different angle by approaching it from a different angle. Right, that bit is technically soldered, but it's very messy, as you can probably see. You can't see anything in this video, can you? Why am I even making it? So what I'm going to do is I'm going to trim the first bit of wire off on the more successful side. I say trim, more snap and bend. And I've just realised that is actually loose, so that's not going to do whatsoever. So there's already quite a bit of solder on there, so I'm going to just try and reheat what is on there at the moment in the hopes that it will go into place naturally. Because solder and circuit boards like this are designed in such a way that when the solder is molten, it wants to flow into the place you want it, i.e. on the little metal holes. And there we go. You see that? It just into place. Next up, according to the instructions, is R3, which needs a 220 ohm resistor. It hasn't given me the colour combination for that, which is a shame. It looks to be red, also red but brown and gold. And that is going into R3, which is one of the lower panel down there. So that goes in there, that goes in there. And, well, you know what happens now, don't you? I think a lot of this bit I'm just going to speed up because I'm faffing about a lot and making a fair few mistakes. Next on the list of things to do is R4, which needs a 47 ohm resistor, which has a gold, purple and brown by the look of it. This is going to require so much editing, my god. Into there. Through the magic of video editing, that looks like it took seconds, but in fact, in the time it took me to do that, there has been a change of currency and a change of monarch. Right, what's next up? Ooh, capacitors. I've not played with those before. Now we move on to the capacitors. Let's start with designator C2. Okay, C1 isn't there. C2 should be a 10 nf capacitor. I don't know what a nf is. There's the small yellow component. So here's the small yellow component I was talking about. Now I can't see if there is a polarity on these because, as you can see, the legs are the same length. Unlike on an LED where there is a longer leg for the positive end. But this little bit in the middle where this orange component goes, there is no plus or minus sign, as far as I can tell. So I am led to believe, oh, hang on a minute. Now there is no plus and minus sign, but with this component, you can see the plus and minus have different shaped slots. So around the positive leg, there's a circle, and if you look really closely, you might be able to see around the negative leg, it's more like a, what shape is that? Square. That's the shape. It's more like a square shape. So I'm going to follow that logic and hope that the circle shape in the middle piece is the positive and the square one is a negative. But then again, which is which? I don't know. It didn't specify in the tutorial, so I don't think it makes a difference. So let's just go for it. Now there's a problem here. You can probably see in this ridiculous looking nose that the bits of solder are touching, and that means that any current that goes through is going to short out because the solder is touching itself, and therefore electricity may be able to bypass that capacitor. So I'm going to need to make that a lot tidier if I want this to work properly. So that's what we have so far. Right, what's next up? I have a feeling it's going to be the little black bit. I am right. Ooh, C3 is an electrolytic capacitor. These have a polarity, so you need to make sure you get it round the right way. What did I say? Right, let's get that in place. So here we have the capacitor. As with all things like this, the longer leg indicates the positive end of the diode, or the capacitor in this case, and that is the positive hole. So I'm going to put the long leg through there, the short leg through there. Let's get going. Turn some light on, make life a bit easier for myself. Hey, there we go. That's better. Right, those parts are in. It's finally done. It's not particularly pretty, but the job has been done. I did make sure that these are two separate bits of solder and that they're not touching, because that could turn out very badly if they are touching. Right, what's next? Next up, it's time to bring in the nuggets, apparently. So we're going to start with the small nugget. Now, this is the chip, and you will see on one end, there's a little dimple cut out of it. And there is also a little dimple cut out at the end of its adapter. So we want to make sure those line up, and we're going to pop the teeth into there. Now, I did have to roll these on their sides a bit just to bend the pins a little, just to get them in place. Like, see, look, already I've bent that. They're very flimsy, but it's okay, you can bend them back. But from what I can tell, that is pretty much what everyone has to do when they have to bend the pins a little to get them to align, and that seems to be okay. How is this the hardest bit I've done all day? There we go. Right, that's in. Now I'm just going to straighten those pins on the adapter out so they're the right distance apart. Now turn this back over. There is yet another dimple on the board there, so we're going to make sure the dimples in the IC chip match up with that dimple. So should be 3 dimples stacked on top of each other. So that goes in there. And there we go, the IC chip is in place. So now we will turn that over and get to big boy hot gluing. Well, that's the first nugget installed. Nice and solid position there. It's getting a bit late, so I'm going to finish this off tomorrow. But of course for you, that'll be just a second. So it's the next day. I've reheated my soldering iron, as you can see. It's hot. I'm going to get some solder just to prime the tip. Get it all over that. Put that to the side. Right, and we're ready to carry on. Now if you hear any kitchen noises in the background, that's my wonderful partner over at the... what's your thing called? That's the one. At the Emporium Next Dorium. I do know, I just have terrible memory. I'm going to link her Instagram on the page now. Go check it out. Right. So next up we have the last IC chip. Once again, we're going to match up the dimples on the ends of the chip with the dimples in the board. So let's just pop that in. Flip it over. And get to it. Well, it's not the prettiest thing, but I've done that. In fact, it's really quite ugly. Quite a few sharp, janky looking bits there. It's not the prettiest thing. But as far as I can tell, there is no solder touching. Oh, apart from one of those nostrils. Maybe. Let's have a closer look. No, it's just an angle thing. It looked like they're touching, but they're not. So there are only two types of components left to add. We have the LEDs and we have the 90-degree header. Now the 90-degree header is fairly self-explanatory. LEDs, obviously, as I've said a million times so far, have a polarity, longer leg being positive, and you'll see that the circles around the holes where the LEDs go have a flat edge on one side, and that edge indicates the negative, if I remember correctly. I had better check that, but I think that is the case. If that is the case, then the shorter leg will go through the side with the flat hole. These are the only bits that I'll solder upside down. You have the LEDs there. We have red ones going all the way around the edge, and the two green ones will go in the eye slots. So it's starting to come together now. But first of all, let me check that I do have it the right way around. I was right. So I'm going to get cracking with the next bit now. It may look like I've done most of the work so far, but I have not. I have soldered so far 36 pins, and including the LEDs and the header, I still have 64 to go. So this bit's going to take quite a long time, so I'm going to speed it up a lot. Once again, just make sure that you're aware I was correct. The shorter leg goes into the slots with the flat edge of the circle on them. The LEDs themselves also have a very small flat edge against the negative leg. In fact, it's so small you can't really see it on camera, but as long as the short leg is going through the hole with the flat side of the circles, you'll be absolutely golden. Now, of course, these are going the other way round. So I'll start by taking a green LED, popping that in there, flipping it over, bending these so that they stay in place while being soldered, and, well, you know what happens next. So I had to stop the video for a second, not because I wanted to, but because my phone ran out of battery. I stopped recording just when I went to go and find my tablet to make sure I was installing these LEDs the right way around. And up to what you've just seen, despite being sped up massively, that actually took me an hour and 20 minutes, and that just killed my phone battery. So hopefully you realise just how long this has taken me. I'm most of the way there. I have 2, 4, 6, 8, 10, 12, 15 of 40 pins left to go. So my soldering iron's back up to temperature. Let's just go. We're almost there. Well, it's taken me long enough. It's been another half hour since I told you how long it had been. But it's finally done. Soldering iron is unplugged. Whew. Now let's have a look at the soldering. We have some good soldering and we have some terrible soldering. This is not good soldering at all. This is good soldering. Hopefully it would all look like that. But I'm still learning. I will improve. Now, of course, we have to test if it works. Well, folks, there we have it. I've finally put it all together. It took a very long time. Now, of course, I've just been playing with solder, so I've washed my hands because I use a lead-based solder. The reason I use a lead-based solder is because adding the lead to the solder reduces the overall melting temperature of the solder, which means your soldering iron doesn't have to be as hot, which means that it's safer for the printed circuit board. Now, of course, being poisonous, you have to take extra precautions keeping yourself clean, but it does have benefits for the circuit board as well. Right, so I'll be honest, I'm kind of dreading this. It might well have gone wrong. We don't know. The soldering down here is very messy because I'm an amateur. I don't know what I'm doing. I spent the longest time trying to make sure that none of the solder went on this gold trim around the edge because that would transmit power, only to realize very near the end that it's actually plastic and it's not conductive. Right. Again, we can see this pin here, square hole. Therefore, that's pin 1, which goes down the back to here to match up with pin 1 there. Right. On you go. Okay. It's on. Now, according to the instructions, it should just work when I turn the Pi on. Let's see. The power bank's not turning on. That's bizarre. Why is the power bank not turning on? Is it a safety thing? If it's a safety feature, it might be a sign that I've... Oh dear. Oh dear. I'm going to plug it into my PC. Try proper cable. So I've plugged a USB cable into the PC. As you can see, the power bank is blinking, which means it's charging. So this cable is fully functional. Here we go. Do we have a fire extinguisher in this house? We might need it. Oh well, let's hope not. Not even getting a power light on the Raspberry Pi. Right, Tell you what, let's take the power out. Come on. Let's take this off. And see if the Pi will turn on now. We have an LED. I'm going to quickly pop open remote desktoping. Make sure everything's working. Okay. The connection's working. The Pi is alive. So, let's try this again, shall we? I think I fluffed it, guys. Well, that didn't go so well. I don't know why. I don't see why adding the components would make the Pi freeze, unless it's a simple RAM and CPU issue. That's very disappointing. I'll figure something out and I'll get back to you soon. So obviously that wasn't an ideal outcome. It's taken me 2 days to do all the welding, soldering, and I put the video off because I had to pick up some furniture. So I've given you a late video and it wasn't successful, and I'm very sorry about that. But I've learnt one of the most important lessons for this experience, which is that things are going to go wrong. Quite phenomenally. I was really looking forward to that. I had a stupid little end sketch in my mind already to celebrate, because my channel recently hit over 100 views on YouTube, which is fantastic. I really appreciate that. It takes a lot of time to create these videos, and despite that, 2 weeks have passed since I started, maybe longer, I can't tell anymore. And I just want to say thank you guys for sticking with me. If you've managed to get this far in the video, then thank you. I hope you enjoyed watching me have a mental breakdown in real time. That was fun. But does this mean I'm stopping? God, no. No. I'm just going to get better. I'll work out what I've done wrong. I'll give it another go. So, you'll be seeing from me again. Thanks a lot, guys. Catch you later.